Okay, there we go. Okay, so for part two, we're going to be talking about forces and resultants under moments about a specified axis, moments of a couple, and simplification of force and couple system. We'll start first with moment about a specified axis, and then we'll go through the rest of the bullets in this video. Okay, you know, before this, you've learned about moments, forces and resultants in scalar and vector notation, and trying to use the cross product as well. Here, with moments about a specified axis, essentially it's just like cross product, except you're not just about um, a moment about a point, a certain point, in this case, a point from O, but you're gonna be rotating about a specified axis. In this case, particular example, it's the y-axis, and here's a given derivation here. So, for example, this the moment at y in its magnitude in scalar form is 4 times the distance plus y. In this case, force applied times perpendicular distance dy. If you want to get its magnitude, so it can also be expressed as the unit vector sub y times cross product r cross f, where ui is equals to the position vectors ry and its magnitude ry. Here is the equivalent determinants and its derivation. And you'll notice that like switching subscript niya from uy to ua, para to simplify lang that this is yung to any specified axis at any axis A. So it could be y, it could be x, it could be z. In this particular example, ito yung magiging forma niya. Okay? So notice here that this is it's not in it's not in bold, but this is yung magnitude. Okay? So when the problem says find the moment, you're given a force and find the moment about a specified axis, and find the magnitude of the moment about a specified axis. This is technically the formula it's referring to. And if the problem says find the moment about a specified axis and express it in Cartesian vector form, you have to multiply it by its unit vector here. Okay, you can find this separately, and then once you find it, you have to plug and play the line. Okay, so the r here is the position vector extending from any point on the axis A, and for in this case, any point on the any axis y, particular matter, to any point on the line of action M. So this is the sort of lesson that it's best shown and explained, really. So let's try solve some sample problems dito. So we have here determine the resultant moment of three forces in the figure below about the x and the y and the z axis. The whole point of this sample problem is to get you familiarized on trying to get the moment about a specified axis. So we're being asked now to determine the resultant moment about the x-axis, about the y-axis, and about the z-axis. So let's give it a shot. So first things first is about the x-axis. So it's referring to this one. Okay, so what are the forces involved? So we have F1 that's rotating about x-axis, so that's kind of easy. So if we're gonna draw a particular one here, essentially it's gonna rotate with the force applying the principle of transmissibility, so we can technically put force 1 here and its perpendicular distance about this x-axis, and this one is about 2 feet. So this is positive. I can tell it's positive because it's gonna be counterclockwise rotation about the x-axis. What else do we have here? We also have F2, and again applying principle of transmissibility. So it's gonna rotate about the x-axis, and it's gonna be just like here, F2, and this is the perpendicular distance. This is what, 2 feet, so that's counterclockwise as well. So that's going to be positive. So when we write, and how about F3? F3, however, is going to act the same line as the axis of rotation. So meaning F3 is 0 for moment at x-axis, about the x-axis. So F3 here will be 0. Okay. Let me clear that drawing again. So yeah, there we go. Right? Okay. So how about moment about the y-axis naman? Okay, so the answer is gonna be wrong. 220 pound force feet or 220 pound force feet counterclockwise. Just don't forget the yeah, don't forget the counterclockwise, the word, and then the arrow. There we go. So how about the summation, the resultant moment about rotating about the y-axis naman? So the same thing then. So in this case, so we're gonna go here naman. So in this case, F1 naman is gonna be acting on the same line of the same axis of rotation. So F1 is gonna be 0. So there's no perpendicular distance whatsoever. Okay, since it's acting on the y-axis, there's no rotation whatsoever. However, with F3 and F2, there's rotation. So rotating about the x-axis, y-axis. So F2 times this perpendicular distance F3. So it's going to be clockwise about the y-axis. So it's going to be negative 50 times 3. And then 40 pound force or F3, it's going to be rotating. So it's perpendicular distance to 2 feet. And it's going to be clockwise as well. So it's going to be negative 40 times 2 pound force feet. And the final answer here is going to be negative 230 pound force feet, or about 230 pound force negative. So that's clockwise rotation symbol, and then clockwise word. How about we try naman yung z-axis? Okay, so this time around, F2 is going to be 0 because the force F2 is acting in the same axis of rotation as z-axis. So what else? Except for F3 and F1. So in this case, F3 is going to be 40 rotating about z-axis clockwise times 2 feet. So that's negative 40 times 2. And then we have F1 rotating about um, z-axis. Fortunately, it's not gonna generate a moment since there is no perpendicular towards. Since there's no perpendicular distance for F1 here, so F1 would cancel out. So it's only gonna be negative 40 times 2. I hope you understand that. So, hindi rin to pwede to eh, kasi this is yung z-axis. F2 hindi rin to pwede since you're acting the same, you're parallel, the force is parallel in the axis of rotation. And this one is not gonna happen because you're acting mismo sa axis of rotation. So that's not gonna happen. There's no there's no perpendicular distance to it. Hindi naman siya about x-axis. Hindi naman siya about y-axis. So the answer here is negative 80 pound force feet or 80 pound feet clockwise symbol. Okay? So I hope you get to practice this muna and try solving it again without seeing the solution first. Let's try one more problem here. So here we have a figure here with this particular dimensions. Determine the moment AB and produced by the force F, this one, which tends to rotate the rod about AB axis. So we're gonna determine the moment, the vector moment AB, and we're being asked to rotate it about the AB axis. So this is the axis of rotation, and we're given this particular dimensions. How should we proceed? Okay. So if you recall our equation when we're finding the uh, the magnitude and its Cartesian vector notation, we have moment about AB is equals to the product of unit vector UB and the cross product of position vector R and cross force vector F, where UB here is in this case UV here is unit vector is equals to position RV, position vector RV divided by its magnitude. And to get its Cartesian vector notation, we just multiply the moment AB by unit vector UV. Okay? So first things first is let's define what's UV muna. The UV is equals to the quotient of position vector RV and its magnitude. We can get it by checking out point P here. So from the looks of it, it should appear as zero point 0.4 I hat, positive zero point 0.4 I hat, positive zero point 0.2 I hat, and 0 K hat. Okay, that's easy enough. And of course, the magnitude will be the squares of zero point 0.4 squared plus the square root of zero point 0.4 squared plus zero point 0.2 squared, and we'll leave it as a unitless unit. This would be the expanded form, 0.8944 I hat plus 0.4472 j hat. The unit vector is again unitless. So we already identified one variable, so we need to identify two more. So next is select position vector cross product with our force. So the thing about this, we can select several actually. We have RC, RD, or in this case RAC, RAB. Okay, but this is only referring to the point C here. Okay, by the way. Could be also with RBD or RBC, since it's we're rotating about the AB axis naman. But for this particular case, we're gonna choose RD since it's gonna be a lot simpler, and it just lies on the x-axis now. So there's a lot of zeros coming up there. Okay, for simplicity, we're gonna use RD. Technically, we can also use RC here, but in this particular case, RC point RC has a K, has a z-axis, has a k hat, and has a k hat and has an I hat, and that's 0 y to 0 j hat theta. But with RD, we only have x axis, so that's only I hat, but we have 0 j hat and then 0 k hat. Okay, so let's just summarize this. So far we have UV vector here, unit vector UV here, and for RD, there we go. So we define the RD and the force here as this particular point, so that's 0I, 0J minus 300K. And RD here is just simply point 0.4 actually. No, actually 0.6 pala, sorry. This one's a little different, but 0.6 I hat. So that's gonna be 0.6 I hat, 0 and then 0. And then our force vector here is 0, 0 minus 300K here, since it's going down. And UV here is placed at the first row, 0.8944 times, and then 0.4 is 0.0, 0.44072 and 0. And then we expand them and then add them up, and then we will arrive with this particular magnitude in scalar, which is 85.896 Newton meter or 85.9 Newton meter positive, so that's going to be counterclockwise. And if you want to express it in Cartesian vector form, all you have to do lang is multiply it again by uv, which is this one, which will generate an I and j hat units. This is going to be 72I plus 36j hat Newton meter. Okay? Just kindly notice yung point. Ito kasi pwede siyang gawing label RAC and then RAB, but you're still talking about yung point dito. Okay? Kasi if it's point from the origin, that's okay. You're still referring to the point at point here, point D, and point RAC, that you're still referring to the point RC, because A is the origin dito. But if you're referring for, like, example, RBC, now that's totally different. You're gonna apply a bit ng RBC, so you're gonna minus RC, point RC minus RB to get yung RCB, RBC pala, sorry. Okay, essentially, position vector formula. I get yung distance problem na naman between the two. So let's solve another problem naman here. So for sample problem number 9, we're asked to determine the magnitude of the moment of force F about the segment OA. So in this case, OA here. So this is O, yung point origin natin dito. And define ng buong axis OA here. So dito yung axis of rotation natin. So pag ganun tayo, ikot dyan. Okay? The OA of the pipe assembly in a drawing shown below. So how do we proceed? So we need to find yung magnitude lang. So we don't need to multiply yung moment natin to its unit vector OA. Okay? So what do we have? We have yung force at 300 newtons. And the good thing about this 300 newtons is we can convert this into its Cartesian vector form by multiplying the position vector over its magnitude. So position vector RCB over its magnitude RCB. You recall yung lesson 3 and 2 natin before. Okay? Yeah, that's RCB there. And then, of course, since may axis tayo na OA, so we have unit vector UOA defined as the quotient between position vector ROA and its magnitude. Okay, our solution here is pretty straightforward. We know that we're rotating about an axis, so our equation is the moment of OA is equals to the unit vector OA multiplied by the cross product position vector R and F. So the question now dito, any position vector extending from any point on axis A. So which are? So ano yung mga yan? Ano yung mga position vectors available? We have, okay, so we have ROD, RAD, RBC, RAC. As long as those position vectors are in the extending from any point on the axis OA, then we can actually use them to get the moment. Okay? In this particular case, actually this is ROC pala, ROC. We can actually use ROC and ROD, which is a lot simpler. RAD and RAC requires you to get the difference between those two distances pa. So there's a lot of work. In this case, we selected ROD na lang muna for simplicity. Since we're gonna be involving lang 0.5 I hat and 0.5 k hat with 0 j hat. There we go. Okay, so let's define muna yung unit vector OA natin. So that's gonna be the quotient ng position vector ROA, this one. In this case, even though I said ROA yan, that's just point A lang. So ano yung coordinates at point A dito? So what? We have point 2 plus point 1, so that's point 3 I hat. And then meron siyang Y na plus point 4 J hat, pero wala siyang A. So 0 yun. So pupuli lang natin yung square root ng mga yan para makuha yung magnitude ng ROP. And we have point 6 I hat plus point 8 J hat. Next naman yung ROD. So yung ROD dito, essentially, we're just talking about yung position ng D dito. Meron siyang I hat na 0.5 and meron siyang 0.5 na K hat pero walang J hat. So which would give us this 0.5 I hat plus 0.5 K hat in meters. And then next up is we should define na yung 300 newtons natin into its Cartesian vector form. Simple lang naman yun. We just apply yung formula na to. So 300 times the quotient ng position vectors RCD and its magnitude. And RCD here is just the difference between two distances lang naman ito eh. I can show you how I acquired it lang naman. So essentially ito siya. And RCD is 300 and RCD position vector RCD is 0.4i minus 0.4j plus 0.2k, and then the magnitude is the square root of its respective x, y, z components. 0.4 squared plus negative 0.4 squared plus 0.2 squared. So how did I do this? The old-fashioned way is, ano ba yung meron sa RC natin? RC natin is simply 0.1i, and then that's 0.4j, and then plus 0.3k. RD natin naman dito is simply 0.5 I hat plus 0 J hat plus 0.5 K hat. And all you have to do to get RCD is minus RD, get the difference between point RD and position vector RD and RC. So you would get 0.5 minus 0.1 at 0.4, 0 minus 0.4 is negative 0.4j, and then plus 0.5 minus 0.3, that's 0.2k. And the simplified version of this, your force in Cartesian vector notation is 200 I hat minus 200 j hat plus 100 k hat newtons. Now, since you have all three ingredients for your formula, all you have to do is substitute them out and create your determinants. So laying out the equation now for the moment of O about axis OA is equals to the product of unit vector UOA and cross product ROD vector and F vector. So ito yung magiging determinants niya. UOA is 0.6, 0.8, and then 0k, 0.6, 0.8, 0k. ROD on the second row, which is 0.5i, 0j, and 0.5k. And then now yung force vector natin, 200 minus 200, and then 200. Expanding yung determinant na to will yield you this. So 0.6, 0 times 100 minus the product of 0.5 and negative 200 minus 0.8 times 0.5 times 100 minus the product of 0.5 and 200. And then finally, k is 0. So this one is 0 times to. So that's going to be 0 naman anyway. Simplifying it, you would be with 60 and 40. So that's positive na. So plus 60, you're going to have 100 Newton meter dito. Counterclockwise is positive naman siya. Yun yung magnitude niya. Do not forget that. So if asked the moment in Cartesian vector notation, all you have to do lang is multiply 100 Newton meter, is this one, by UOA. So 100 times 0.6 I plus 0.I j. So you'll give it, you will yield you 60 I hat plus 80 J hat Newton meter.